lesson, we will cover the topic of aging of dynamic MAC entries in the MAC table. Why do the entries age? And if they do not age, what would be the consequence of it? That's what we'll cover in this topic. Further, we will go over a couple of important questions that get asked in interviews related to aging of MAC entries in the MAC table. So you have seen this topology. I've used it in the previous lesson also for MAC move. We will further build upon the concept of MAC move in this lesson. So this is our topology. And now if PC3 wants to send data to PC6, it will create a frame, source address C and destination address F. The frame will be sent out. The hub will flood it. For now, just ignore what PC7 or PC8 do with it. Just ignore it. We are just focusing on the switch. The switch will receive the frame and then it will learn the MAC address C on port P3. Up till now, this concept of learning the MAC address should be clear to you all. So I'm not going to go through the details explanation. So clear and simple. Switch 1 receives the frame and it learns the MAC address C in the port P3. And along with that, it also sets a timer here in it. That now it has received it. That's the reason this 300 value is there. Okay. Good. Next, we'll say PC1 wants to send data to PC3. It will create a frame and send it out. Okay, switch S1 receives it. Now see, I have depicted here the age to be 270 for MAC address C. That means it has been 30 seconds. 30 seconds have elapsed between when PC3 had sent out the frame. That's the reason after 30 seconds, this age, the MAC entry C has aged down from 300 to 270. So after 30 seconds, this one is receiving here, this frame from PC1. So PC1 has sent the frame. Okay, now switch learns the MAC address A on port P1, makes an entry with the timer set to 300. Good. Okay, and now the switch will check the destination address. It finds it in the MAC table and then it will forward it out of port P3. The hub will flood it. PC7 and PC8 will drop it and PC3 will accept it. Okay. This is how it will work. Good. Now, I'm just going to use the same concept of MAC move here. With these entries being here, what happens? Now, if I will disconnect the cable from here and move it back here, what am I doing? Disconnecting the cable between the hub and the PC3 and removing the PC5 and moving this PC3 to here. So, kind of simulating a MAC move. Okay, so this has happened. The PC has moved, but PC3 is not going to send data for now. If it would send the frame, then switch will update its entry, but PC3 is not sending its frame as of now. So now let's see what happens. So we have disconnected the cable and moved PC3 from this port of this hub to this port P4 of the other hub. In this scenario, if the PC1 sends again data to PC3, its intention is to send to PC3. Okay, so it creates the frame and sends it out. And now switch S1 receives it. Switch S1 will do what? It will refresh the entry in the MAC table for A and move to the next step, which is look at the destination address of the frame, which is C, and knows that C is in the port P3, is reachable via port P3. So switch S1 doesn't know that the PC3 has moved to here. It only knows that it had received a frame from PC3 on port P3, and that's where it is awareness. Anytime a frame comes with port PC3, that is for destination MAC address C, S1 is going to follow what it knows in its MAC table, in its memory, and that is that C is available on port P3. So it will forward the frame out of port P3. Okay, like this. Now the switch, the hub will receive this frame and flood it. And PC7 and PC8 will drop the frame. Okay. Now, this will continue every time, right? Yeah, now there's the further time has gone by. That's why the entry in the MAC table has gone down to 200. Let us say further, again, PC1 sends out data to PC3. So what happens here? The age is 90 seconds, so there is another 110 seconds gone by from 200 to 90. So 200 to 90 seconds have reduced. So now again, we are sending frame from PC1. This one again, what is happening is it is PC1 intending to send to PC3, but because switch one is not aware of the right place where exactly PC3 is, it is only aware of the old entry. So the entry is old, it is inaccurate, it is a stale entry, but switch one has no other option but to forward it based on what entry it has. So this will continue the traffic when it is going to the wrong destination. We call it as black holing of traffic. The black holing of traffic will continue like this. Right? We'll send it out again, and this will again get black hole. PC3 should have received it, but it could not because switch one is following what it has got in its memory in the MAC table. Okay. Now this will continue till this entry ages out. Right? Good thing is because the entry is gradually ages out, this will gradually get deleted, right? Finally get deleted. This countdown will happen 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0, and then this entry will go away like this. Right? Entry will go away. So the entry for MAC address C is now gone. So in this case, now what would happen? If now PC1 wants to send again data to PC3, creates a frame arrives on port P1 of the switch, it refreshes the entry, and then since the destination MAC address is not there in the MAC table, switch will flood it. Okay. The hub will forward it to that side and switch will forward it to this side. They all will drop it because the destination address does not match. Next, we will see what happens for the hub from this side. So hub will take this particular frame and then it will further flood it. Now PC4 and PC6 will reject and drop it, and PC3 will accept it. Okay. So this way, the concept or the key takeaway here is that if the aging is not there, then the black holing of traffic will continue because switch will have a old entry in it. So you have to make sure that switch always maintains the MAC entry. And if you think about it, that's why every time a switch receives the frame from the same source address, it refreshes the entry. So one concept is about refreshing its entry. How does it refresh the entry? If it is received on the same port, it will refresh the timer for it. If the same MAC address is learnt on a different port, it considers as MAC move and changes the port corresponding to that MAC in the MAC table. Okay. And the other concept is if you are not getting a frame from the same source address, then the entry will keep on getting aging out, and finally the counter or the timer will go to 0 and it will age out, and the entry will get deleted, purged, or removed from the MAC table. So aging of MAC entries helps us prevent infinite black holing of traffic. If the entry would not remove, then the traffic will keep on going into the wrong port, and that is why we call it as infinite black holing traffic. Okay. Second thing is, once the MAC address gets aged out, flooding would resume, and the PC for which data was intended has the possibility of receiving it. Right here, we had moved the MAC, the PC3, and then you saw how once the switch, once it entry for MAC table in the MAC table for MAC address C got deleted, it started flooding it again, and then that's how PC3 again received the frame. That's the concept of aging of entries of the MAC table. Okay. For this, the important questions that get asked are: explain the concept aging of MAC table entries. Second, what would happen if the MAC table entries did not age? Then the interviewer is trying to ask you what exactly is the concept. You should be able to explain that with using a topology, right? That is where the next question also comes in. Explain the concept of black holing. So second and third question build upon each other, right? What would happen if the MAC table entries did not age? There's a possibility of black holing of traffic. That's what you should be able to explain using a topology. And that's a short answer, but and the third question is, using a topology, explain the concept of black holing of traffic. And how does aging of MAC table entries stops black holing of traffic? So these are the important interview questions. If you know the answers for it and are able to explain this concept clearly and crisply, then you would be whole. Right? No issues with you for clearing that particular round of interview. Okay. Okay. We are coming close to the topic of layer 2 fundamentals for switch. So in the next lesson, I will cover the concept of full duplex mode of operation of a switch. Remember, when we are talking about discussing the concept of how hub operates in the half duplex mode. Half duplex mode is when only one side can transmit and the other can receive. Full duplex mode of operation is when both endpoints can transmit and receive simultaneously.